This is Caleb Cadenhead. My project is accompanied by Zoe Cobb and Katie Gilman. Our project is over Antoine Lavoisier and why he is considered the father of modern chemistry. So Antoine Lavoisier was born in Paris, France, and he became an aspiring chemist. He was known for his countless experiments, and these experiments he conducted daily. Um, these experiments led to a lot of his breakthroughs, and it was just the countless experiments are what shaped his name as being the father of the modern chemistry because it allowed for things like his nomenclature of the periodic table, for example. So Antoine Lavoisier would go and perform these experiments, and his wife would accompany him. His wife, Marie Anne Pauls Lavoisier, would she would accompany him and aid him with these experiments. It just consumed so much of his time. This is how she was spending time with him. He adopted the metric system into chemistry, which was very huge for science. And he also decided to not consider airs as an air, but as a gas. Discovered oxygen and hydrogen. Also, the law of conservation of mass, stating that mass remains constant; it cannot be added or subtracted from. So mass is mass, and you can't just take away from it. Uh, he wrote the first extensive, detailed element list and gave them names. It was the first detailed list. Why he's first in the chemistry nomenclature. He discovered that oxygen was also combustible, which it helped him to conduct more of his experiments and to make more breakthroughs after he discovered that oxygen was combustible. Another thing that he decided to do experiments on and come to the conclusion that water is not an element, it's rather just a pure compound. Water is very pure, but it's a compound of mixed elements put together. Lavoisier's life was full of research, and the unfortunate thing is that he was found guilty, which it was falsified, but he was found guilty and executed by a guillotine. So the amount of information that Lavoisier could have unfolded is now lost because of some falsified charges. He was beheaded in 1794, which later they decided that his charges were acquitted, that he was actually innocent.
Lavoisier was the first of his time to create a detailed elemental list. Because of this, his influence was far-reaching, and he caught the attention of many chemists of his time. Lavoisier was responsible for providing the theories and discoveries, and those who came after him often followed up with mathematical work to support and confirm his findings. One such instance occurred when Henry Cavendish, an English chemist, used Lavoisier's work to determine the percentage compositions and changes in weight of organic compounds. Lavoisier had provided the building blocks by discovering and categorizing the elements. Cavendish was then able to follow up with the mathematical proofs needed to explain the percentage compositions of the compounds. Both men's work were extremely important, but neither would have held as much weight had it not been for the other. One of the greatest ways that Lavoisier influenced the world of science was in his study of combustion. In 1774, scientist Joseph Priestley discovered the element oxygen for the first time. At the same time, Lavoisier was studying chemical reactions, but had reached an impasse because he could not determine what was causing certain substances to burn. He was fairly certain that the phlogiston theory, which was widely accepted at the time, was false. This theory held that materials that burned contained a fire-like substance inside of them that was released upon the substance burning. Lavoisier was in the minority in believing that this theory was false, and it had been held true for almost 100 years. But he believed that there had to be a better explanation, and he was determined to find it. It just was not until Priestley's discovery of oxygen that he was able to do so. When oxygen was introduced as an element, it caught Lavoisier's attention right away. Because of this, shortly after the discovery, Priestley and Lavoisier met in person for the first and only time to discuss their separate discoveries and the impact they could have on one another. After conversing, Lavoisier believed that Priestley's discovery could be the key for explaining the burning effect, and he chose to replicate the studies done by Priestley to be sure. Prior to these studies being done, it was believed that common air was one simple substance that was uniform and always the same. But when completing the study, Lavoisier found that this was not the case. Common air was not a simple substance, as had been believed, and instead was comprised of many different substances, one of which was responsible for burning. He believed that combustion occurred when a reaction between a metal or organic substance and that part of the air, which he called eminently respirable, and then later oxygen, took place. Lavoisier's discovery proved correct and largely important in the scientific community. However, had it not been for the manner in which he researched, this might not have occurred. Lavoisier worked in a way that was ahead of his time. He studied concepts that others could not understand for years, even when he didn't find answers. It was for this reason that when Priestley presented his idea of oxygen, Lavoisier was ready to interpret it in terms of its relationship to combustion. He had done much research in the years leading up to the discovery, and this set him up for success when the discovery occurred. Lavoisier frequently acted in this manner, making many groundbreaking discoveries during his life and setting himself apart as a leader in the chemical revolution.
Lavoisier has influenced much in the modern world. He's done this by determining that oxygen was a key substance in combustion, and he even gave the element its name. During his experiments, Lavoisier discovered that water was a compound made of hydrogen and oxygen. Prior to his discovery, scientists throughout history had thought that water was an element. He developed the modern system of naming chemical substances. His giving new names to substances, most of which are even still used today, was an important means of forwarding the chemical revolution. It was Lavoisier and no one else who firmly established the principle we now call the conservation of matter. This idea is that matter is neither created nor destroyed during a chemical process. Lavoisier's obsessive attention to the weights of his experimental ingredients allowed him to make many of the discoveries for which he's remembered today. And more than 2 centuries after his death, this principle remains the bedrock of chemistry. An important thing to understand about Lavoisier is that we still use a lot of his discoveries today. Lavoisier spent a lot of time isolating elements and breaking down chemical compounds. Like mentioned earlier, he invented a system of naming chemical compounds that were made up of multiple elements. Today, you see a lot of those on the periodic table. He took the confusing chemical language and turned it into something a bit more clear to understand. We even still use his discoveries of the conservation of mass. This leads us into what schools are using in regards to what knowledge Lavoisier provided. Texas TEK's core curriculum calls for students to learn about the conservation of mass as well as being familiar with the periodic table, both of which Lavoisier plays a major role in the discoveries of. In 8th grade, students are required to develop a conceptual understanding of chemical reactions by investigating how evidence of chemical reactions indicates that new substances with different properties are formed and how that relates to the law of conservation of mass, as well as write and balance chemical equations using the law of conservation of mass. Students will be instructed to describe and research the history of chemistry and contribution of various chemists such as Antoine Lavoisier. Lavoisier even helped construct the metric system, which is the system used to measure in science. Lavoisier has played a major role in the field of science through his hard work, devotion, and discoveries, and because of this, he deserved the honor of being known as the father of modern chemistry.